Welcome. It's our last day of material. I took a screenshot of our Moodle quiz and I'll put it in here. And I was trying to find, you know what, maybe we'll crop this here. So it's a little bit bigger. Come on, there. All right. All right, so great work on test 3. I haven't made any adjustments, but I saw a lot of 100%ers in there, so that's really great to see. I'm really happy about that. And it is pretty typical that the third test is feeling pretty good because it's very similar to the second test in a lot of ways. So we're going to start the last day of new material today, which is mortgages, which is we're not really learning any new techniques. It's just applying it to this special layout of a problem. Okay, so you did test number 3. Good job. And today we're going to do section 8.1, which is the only section in chapter 8, so it's a little misleading, but that's the whole chapter 8 is on mortgages, and I've posted the problems and the solutions, but also this worksheet. So this is what we're going to do today. We're not going to have time to do all of them, so I've posted the solutions as well. Okay, so whatever we get through, I made a huge mistake, a scheduling error, so I am going to have to end class about 10 minutes early today. I'm sorry about that, but also you guys deserve a break. So that's why the solutions are here in case you need them. And then your last assignment and your last quiz. Aren't you so sad about that? Last assignment and quiz. You can do it. Well, besides the final exam, of course. Okay. Then there's no classes on Monday because it's Easter Monday. And we'll just have, I'm just going to outline. We won't have time to do very many problems, or I'll have some that have been kind of sticky, but not a lot. Not a lot at all, but I do give you practice, so you're okay. But we will go through the format of the final exam. That's going to be our main goal for Wednesday next week, right? And so I know it's kind of a crazy time in the term, so if you can't make it, that's totally fine. I'll post the video. Yeah, you've already done all the learning. The only new thing is here. So it's all here. Just keep it in here a little bit longer and you'll be fine. All right. So let's see here. Chapter 8. Is on mortgages. So mortgages are annuities, right? Mortgages are when we make regular payments. Okay. So here I'll underline that to show that it's a new section. So mortgages are annuities. So we already know how to solve many parts of these problems, right? So we already know the techniques we need to solve these problems. Techniques we need to solve these problems. Let me just see. I'm going to mute everyone. There. All right, so we already know all these techniques. They're annuities, so they can be, payments can be at the end of the payment period, they can be at the beginning, right? And so, right, payments at the end of a payment period are just ordinary annuities. I think they're called ordinary annuities. I think, or general annuities, maybe. Usually we just call them annuities, right? But if the payments are at the beginning, then they're annuities due. It's so bizarre. It kind of seems like my Apple Pencil is running out of ink and it's all weird. Last time that happened, I needed a new tip, but looks fine. But so sorry, it's a little bit weird. All right. The new thing about mortgages, okay, so what's new is that we're going to make an amortization schedule. New is we will make an amortization schedule. So what's an amortization schedule? If you haven't had a mortgage yet, right, which a lot of you haven't probably, then you won't have seen this. But as soon as you get a mortgage, you're going to see an amortization schedule, and it's just a list of all the different payments that you'll be making over however many years you're mortgaging for, and it's just a breakdown of all the payments. How much is going towards the principal and how much is going towards interest, right? Because we have to pay interest. Okay, and so today we're going to look at how do we build an amortization schedule. So an amortization schedule is a schedule of payments with a breakdown of the principal amount and that's the amount paying off the loan, the amount going towards the loan, and the interest amount. Right, you have to pay interest. Okay, and so the amount of interest paid. Okay. And the remaining balance. I'll say as well as the remaining balance. All the problems that we're going to see in this section have a table that looks like this. Okay, so some version of this table. I'm going to completely ignore the question for now. We will work through it, But what I want to do is bring in this table and just establish facts that we need to solve all these problems, right? Because all of the questions will be the same. So we need to know the rules, right? So here's another table, here's another table. I think I gave you 3. In the assignment, in the quiz, you will have a table to fill in, right? And so we need to know the rules for this amortization schedule. Okay. So here, this is an amortization schedule. So it looks like this. And there are rules. In this chapter, we will learn the rules for filling in this table. Okay. But first, let's talk about these headers. Okay. You've got your payment number, right? First payment, second payment, third payment, etc. Right? You've got your payment amount. Okay. You've got the interest amount, and you've got the principal amount, and then the remaining balance. Okay. So let's talk about this first row. Rules for the first row. And let's see here. Rules for the first row. We need to know how to start. Always helps. We always start at 0. So start at 0. There's no payment, no interest, no principal. The only thing you have at payment 0 is the initial loan amount. Now, most of these problems, this can be applied to any sort of loan, car loans, etc. But we're going to talk in terms of mortgages, but then of course it extends to the rest. If you have a down payment, right, you take that off of the original cost. You don't need to pay interest on that because you've already paid it back, right? And so if there's a down payment, you subtract it. So this is just the initial loan amount. So that's your first row. Pretty basic. Let's talk about the payment number. Copy. Oh, looks like it didn't copy. There. I'm worried I'm gonna run out of colors. That's okay. So we know that the first payment number is always number 0. Then 1, 2, Often we pause and I ask you for, let's say, the 100th and the 101th payments, for example. And then let's say N is 300, right? the total number of payments. Total number of payments. Let's bump this up so I can write some more about that. Okay. N is the time times F2, which is the payment frequency. We've seen all this before. We've had to find N. N is the number of payments. And so that's true. And if you think about it, right, I know this might feel overwhelming right now, but if you think about it, you're just outlining what each payment is. Okay? And so then you have the 0th payment because you need to establish how much was owing, and then payment number 1, payment number 2, all the way down to payment, the final payment, right? And maybe, I'm not going to say, maybe I shouldn't say 300 specifically, sorry, N. Because it's going to change. And depending on your payment frequency, how long you're planning to take, and all sorts of things. Okay. Let's see here. I kind of went rogue off my notes, so I just want to make sure that I'm not missing anything before I move on here. So here, the payment is the payment amount. Copy. Payment is the payment amount, which is, well, the first row was blank because you don't make a payment on your 0th payment, but you do make a payment, the payment amount, which is PMT, right? In our formulas, we know how to solve for the PMT, right? If I have a problem, I know how to solve for the PMT, so that's good. That's going to come in handy. Okay, and so I've got this payment amount, all the way down. The change here is that now it's going to be the amount remaining. Okay, so this last payment is going to be different. Okay, it's often different. Yeah. This final payment must be the previous balance. Okay, and so what that looks like here we have the balance. Okay, so here, if it's your last payment, you have to pay all that off. Okay, and so the final payment must be the final balance owing. Otherwise, the loan is not paid off. Let me just give myself more room here. Otherwise, the loan is not paid off. Okay. So this one is going to be the final balance. Okay. Okay, let's see here. It's another color, purple. Purple I'm going to use for the interest and the principal because they go hand in hand. Okay. Each payment, so each PMT is made up of two parts. Okay? Some paying off the principal and some paying off the interest. So each PMT is made up of two parts. The interest, which is what? The interest, the amount of interest, which is going to be, so how we find the amount of interest is we take the previous balance, okay, and we multiply it by I2. Okay. I2 is the periodic payment amount or the periodic interest rate. Okay, and so let's see here. The interest, which is I2, which you're going to have to calculate, okay, times the previous balance. Owing. Okay. And the principal amount is going to be your PMT minus the amount of interest. Okay. So whatever isn't going towards interest, because you have to pay the interest first, right? Otherwise, the bank won't let you borrow money anymore. They say, okay, well, first things first, you pay us your interest that you agreed to, right? And then whatever is left over, we'll put towards and we'll pay off your loan, right? And so sometimes that amount going towards paying off your loan is very, very small. In fact, initially, okay, the amount going towards the principal is very small, and then it increases as the amount of the loan decreases. Yeah. And so here, the amount of the principal is going to be, and let's see if I can, is going to be increasing. And I only tell you this because it's going to be a really good way to be able to check your work, right? Is the principal amount, is it increasing as the payments go on? And here, the amount of the interest is going to be decreasing for each payment, right? Just by a little bit, usually pennies, right? But over time, right? And so what we have is in the beginning, there's very little going towards the principal and a lot going to pay off the interest. Here, I'll go lower, right? But then as the amount owing, right? So the principal pays off the amount owing. So then as I pay it off, the amount in interest that I need to pay is going to decrease, and the amount that's going towards the principal is going to increase. Yeah. All right. So here, this final interest amount has to be interest on the second to last previous balance owing, or the previous balance owing. Okay. And so, and then the principal is going to be 0. Okay. Let's see here. Oh, I think I missed it. I missed something. The final payment must be the final balance owing plus interest. Sorry, I forgot that. I knew there was something I missed. Okay. All right, so then we can talk about, let's see if I have a different color here. The balance. So this balance here, we said was the initial loan amount. Yeah. So then you have your loan minus the principal for that. And then you've got this running balance where you decrease the amount by the principal payment. And then finally, so here, final balance owing, and maybe what I'll do is I should make these little boxes here. So this is the loan amount minus the principal that you've calculated. Yeah. Here, this value is the final balance owing. Final balance owing. Yeah. And as a rule, the final balance at the very last payment must be 0. Okay. So here, the balance after the final payment must be 0. Okay. Now let me just skim these so I didn't miss anything again. Payment amount. Okay. Good. I did it. Said everything. All right. So there are some rules. Most of them are about the final 2 rows or the final row. Okay. So let's go through and do this example, this first example that we have. Let's do this. So I haven't brought the table in quite yet because there's some groundwork that we need to do. For example, we still need to find I2, okay? Or we can use the calculator, but we will need I2 to calculate the amount of interest regardless. So I always start with just finding I2, for example, I think it makes it easier. Okay. All right, so let's see here. Something crashed in the hallway. All right. Norm wants to purchase a home in West Kelowna for $308,000. Don't we all, Norm? He intends to make $100,000 down payment. Impressive. With the remaining payments being made bi-weekly over a 25-year period at 4.75% compounded monthly. Construct a partial amortization schedule showing details of the first two payments, payments 324 and 325. So I'm going to show you how to do that. And the final two payments. What are the net interest charges? Okay. First things first, though, we don't know what the payment amount is, right? So we know we're going to need that. But first things first here. So step one, I'm going to say is calculate I2, right? Just so you don't forget it. In fact, in the Moodle quiz, I'm pretty sure I have a little box asking for I2 because you need it. Okay. So step one is to calculate I2. Okay. So I2 is 1 plus I1 to the power of F1 over F2, then minus 1. Okay. How I think of it is I'm moving from a compounding frequency of F1 to the payment frequency of F2. Now the compounding frequency matches my payment frequency, which is what I need. Okay. So we have the rate of 4.75 compounded monthly, and payments are bi-weekly. Okay. So the compoundings per year is F1, which is 12 monthly, and the payments per year, which is F2, is bi-weekly, which is 26. Okay. So now I2 is 1 plus 0.0475 divided by 12 to the power of 12 divided by 26 minus 1. Okay. Let's see here. I want maybe here. Oops. Okay. All right. So I've got bracket 1 plus 0.0475 divided by 12, making sure that it's just the 0.0475 divided by 12, bracket to the power of 12 divided by 26, and then step it down minus 1. So I get here. Oops. Hey, where did it go? Undo. What? It disappeared. I don't know where it went, but also I undid too much. And let's just see if I can just get it back here. Okay, so I2 is 0.001824980058. I'm going to save that as I2, but I just wanted the calculation in there first. Step 2. Calculate N, which is the number of payments. We're making payments over a 25-year period, and we're making bi-weekly payments, which means N is T times F2, and maybe I'll just start it fresh on a page here. N is time times F2, so N is 25 times 26, which I have here is 650. Payments. Great. What are some other things that we need, right? Thinking back to our table that we're ultimately going to want to fill in here, right? I have the number of payments, which is 650, right? So that's good. I'm going to need my payment amount, right? So that's our next step. And we have our I2, which will allow us to find the amount of interest. And then the last thing that we need is the balance amount, right? How much is this loan for? Okay. Step 3. And you don't have to do them in this order, but I like to break it up into steps. And then if you already have some information, then you can just put it in, right? But step 3 is going to be find the payment amount, which is PMT. Now I am going to just use the calculator, right? Now we should be fairly comfortable using the calculator, and it's going to save us a lot of time. In fact, we need to use the calculator. And so we don't need to, but it's easier, a lot easier. All right. So what I'm going to do is I'm going to list the values across the page so that it's not taking up pages upon pages, because we are going to need to do a lot of these calculations, these calculator calculations. So N, the interest per year, the present value, the payment amount, the future value, the payments per year, the compoundings per year, and the mode. Okay. I want to solve for the payment. Okay. So I'm going to put a little star here because that's the one that I want. And we already know how to solve this problem. I just want to find the PMT, right? And so N is going to be 650. The interest per year is 475. The present value is the amount of the loan. So I guess, you know what? I'm going to sneak it in here. You've probably already calculated it, right? Because it's 308,000, but then he makes a down payment of 100,000. And so then the remaining amount that he has to borrow is 208,000. So I'm going to do something sneaky and just sneak it in here and call this step 4 later. But for now, step 3, find the initial loan amount. I'm pretty sure that you is 308,000. Pretty sure you've already done it, even if it was just mentally. So 208,000. In terms of our calculator, so now I'll call this step 4. Sorry about that. I forgot that we need it for the calculator. In terms of our calculator, it's going to be a positive amount, right? I get 208,000 from the bank. I decide to go and buy a house, right? It's not really how it works, but that's how it is, right? So I get 208,000 and then I have to pay it off. The payment amount is what I'm solving for. The future value, now, once this loan is paid off, the future value has to be 0. Right? We already found the payments per year is bi-weekly, 26, and the compoundings per year is 12. And here, the mode is going to be at the end. Now, the reason for that is because the end is the default. And because it doesn't say anything where it specifies, right? So with the remaining payments being made bi-weekly over a 25-year period, it doesn't mention anything about the beginning, and so it has to be the end. Okay. So I want to make a note of that here. The question must specify if it is at the beginning otherwise use end. Okay. We are ready to calculate this thing. And let's see here. I'm gonna turn my iPad. Oh, of course. I feel like if I hit this close, okay, it worked. One thing that I noticed right away is that I am in begin mode, which I want to change. And so that's going to be the first thing that I change just because I don't want to forget about it. So second begin, second enter. Now I'm in end mode. So 650 for my N, 475 for my interest per year. It's got to feel good, right? You're probably feeling pretty comfortable entering these values, right? So 208,000 for your present value. I'm going to put in 0 for my payment amount. I'm going to come back and calculate it, but I just like to fill every slot every time. And my future value is 0. Now my payments per year is 26, enter, and scroll down. Compoundings per year is 12, enter. Scroll through, make sure it's saved. Just double check that you're in end mode, because if you're in begin mode, it'll have a little note at the top of the screen saying BGN. Okay, it doesn't. So now I can compute PMT. Okay. Gonna bring this in here. So here, the payment amount why is it negative? It's negative because we have to make those payments, right, back to the bank. 546.73, right? Rounding properly to 2 decimal places because it's money. All right. So we're now going to be able to fill in the first 2 rows because the 0th row doesn't count. Okay, so we can now fill in the first 2 rows, or 2, I'll put 3 in brackets. I'm gonna go back to the original here. Grab a chunk of it. Oops. All right. Remember the rules? I'll use light blue so it's easier to tell what I wrote versus the printed page. Remember, payment 0, okay, payment number 0 has nothing except the original balance, 208,000. Okay. The payment number for the first 2 rows is nice and easy. 1, 2. The payment amount for each of these is 546.73 until the very last payment. Then we need to do a little bit of work, just readjusting, making sure everything's paid off, right? Interest and the balance. Okay. And so 546.73, 546.73. That's the key with these mortgages, is that in general, they don't, the payment amount stays the same, right? It doesn't matter how long you're paying it off for, right? The payment amount is always the same. It's just the makeup of how much goes towards the interest and how much goes towards the principal is different. Okay? So now the amount of interest here is going to be the previous balance, 208,000 times I2. Okay. And let's see if I can. It's the previous balance times I2. So in this case, 208,000 times I2, which we already solved for here, which I'm going to use this, copy. There. It keeps going, right? So you don't want to use any rounded values because that'll catch up with you in the end. Okay. So let's see here if I can. I'm going to call this I. How about just I? That's fine. Okay, so then I have 208,000 times I. Which means this amount of interest, and let's see if I can move this over here. This is 379.595852. Okay, I guess I shouldn't put the dollar sign until I've rounded. So here, 379.60. Right? The bank wants all their money, right? So you have to round properly. But besides that, not too bad. Okay. So let's see here. Can I do that? If you pay $546.73 and $379.60 goes towards the interest, the remainder is of course going towards the principal. Okay, so that's great. So here, the principal is, let's see here. Is the PMT minus the interest, which is 546.73 minus 379.60. So 546.73 minus 379.60. 167.13. Doesn't seem fair, right? And it's not, but that's how these loans work in the beginning. Okay, so 167.13. That's how much you get to take away from the balance. Okay. So here, this new balance so the balance is going to be the previous balance minus the principal, which in this case is 208,000 minus 167.13. And then slowly but surely, we're going to pick away at this loan. Oops. 000 minus 167.13. So my new balance owing is 207,832.87 pennies. Screenshot this and bring it in. Close this off. Of course, you can use Excel to do these problems, but one thing that I will say is we're doing a lot of rounding, right? Because we're working with dollar amounts, right? So this is one of those cases where we actually don't keep all the decimal places. We round properly at each step. And so then, unless you set up your Excel spreadsheet to round each time, right, it might make a mess. So here, whoops, now we have 207,000, where is it? 832.87. Okay. Good. Now we do it all over again with the second row. Okay. We already have the payment amount, so we're going to move a little bit quicker this time, or a lot quicker, right? So the second row here, let's see here, let's use just dark green. Oops. So now I have that previous answer. So what I'm going to do is I'm going to multiply it by I to find that interest amount. So that previous answer times I, which is I2, okay, which means that the interest amount is 379.29, right? Rounding properly. Slight change, ever so slightly, right? But we're paying just pennies less in interest, but over time, that's going to make a difference, right? And why are we paying less in interest? Well, because we have a smaller amount owing, right? A smaller amount that we have to pay interest on. Okay. 379.29 from the payment amount. So I have 546.73 minus 379.29. Oops, I missed a 7. Makes 167.44, right? So you're already starting to see that shift, very small, right? Which then I can take away from the previous balance, which is 207,832.87 minus that previous answer, So now my balance is 207,665.43. Now, of course, I'm going to screenshot this and bring it in. Oops. And I'm going to highlight where we did those second row calculations or second payment. Maybe I shouldn't say payment though, because maybe it's confusing. Oops. So here's that second row information that we got. And in theory, you know, the table keeps going and going and going and going. If we go back to the question, okay, we were asked to construct a partial amortization schedule showing details of the first two payments. That's done. Now we want to do payments 324 and 325. Okay. And the final two payments. Okay. And then there's a follow-up question, but let's focus on these payments 324 and 325. Just as this first payment row relied on having a previous balance, we're going to need the same thing. So to fill in payments 324 and 325, we will need the previous balance, which is the balance at row 323. We will need the previous balance at row 323. Okay. How can we do that? We're going to use the calculator, of course. And so what I'm going to do is I'm going to copy this because a lot of things stay the same. Paste. Now I know the payment amount is, it has to be negative, otherwise I wouldn't be paying things off, but it was negative 546.73. Yeah. And now what's going to change is that this, I'm going to change to 323. Yeah. The interest rate stays the same. The amount I borrowed stays the same, right? And the payment amount, I know, and make sure you have a negative. Otherwise, you're borrowing, right? You borrow 208,000 and then every two, oh, whoops. Didn't mean to have the highlighter on. Wanted to have the pointer on. Every two, biweekly, every 2 weeks, you'd be borrowing $546, and that's not what you want, right? So you have to have this negative here, otherwise that's what you're doing. So now what we want to know is we want to solve for the future value, right? The payments per year is the same, the compoundings per year is the same, and the mode is the same, right? So a lot of things stay the same, of course, but now we need to find the future value. So let's do that. Okay. Okay, I have this, and it is my payment already, but I'm going to change it to 546.73 negative. Oops. Delete. How do I clear? 546.73 negative, right? Because I want to have that rounded value for my payment. So now I'm going to get sneaky, and I am only going to change the end 323, because what's going to happen is everything stays the same until I change it, right? And so now I don't want to make any changes. I just want to go in and compute the future value. So now I have this future value. In terms of the table, of course, it's not negative, right? But if I wanted to just square up today, then what I would owe is $134,546.11. Okay. And so in terms of our table at row, let's see here, copy, paste. Now let's see if I can grab this. I don't think it's going to be easy. What I'm going to do is just make a note to myself, 0, 1, 2, There's usually enough rows to have one row of dots in between to indicate that it's nothing there. Then 323, 324, and 325, right? We were asked for 324 and 325, but in order to get it, I need the previous balance at 323. So then, we'll fill this in later. But for now, we're going to work on this here. Now, I do know the payment amount is $546.73. I don't know the amount of interest and the amount of principal, because what would I need? I would need the previous balance, right? I would need the balance at 322, but that's the reason we did 323. And so now what I can do is I take this amount, rounding properly, and it goes here. 134,546 and 11 pennies. Now I can use that to calculate the amount of interest, right? And the payment amount stays the same for all three of these, 546.73, 546.73. Okay, ready? Let's see here. My previous balance, so we start with calculating the interest, 134,546.11, 134,546.11 times I gives me the amount of interest that I have to pay is 245.54, rounding to 2 decimal places, making the principal amount owing, the payment amount 546.73. It's 546. Yeah. Minus 245.54. 301.19. So here now we've transitioned, right, to we pay less in interest than we do on the principal. So now we're paying off more than we're paying in interest. So that feels good. And then we have 134,546.11 minus that previous answer, right? Because I need to take that off of the balance. And now my new balance is 134, 243.92. Now I take that and do what? I multiply it by I, or I2. The previous one times I. 244.99. 546, oops. New line. 546.73, oops, 73 minus 244.99. It's on sale. 300.74. 134, 243.92 minus that previous answer. Now I owe $133,943.18. Haha. So let's see, I'm going to screenshot this. Close it up and bring it in. Picked up here, I think. So that's going to show you what order to do these calculations, right? But once you have the previous balance, right? Or rather, once you have your payment amount, right? That's not going to change until the very last row. Okay. And so then you're just relying on the previous balance, multiply it by I2, and then take that away from the payment amount to find your principal amount, take the principal amount off of the balance, and then you do that song and dance over and over and over again. Right? And so it's actually kind of fun once you get used to it and you figure out the procedure, and then you say, oh, okay, yeah, sure, I can do this till the cows come home, and we will. How about the last rows then? And maybe what I'll do is I'll just do this. So now, let's see here. I want to show, or rather, these two were here. Now I want to do the same thing for the last two payments, right? I think the question asked for payments 324 and 325, done. And the final two payments, we know there are 650 in total. And so let's count backwards then. 650, and maybe I'll use 650 is the last payment. So 649 is the second to last payment. And so that's the last two rows. But just as before, I'm going to need the 648th balance. 546.73. I don't know this. I don't know this. But I will be able to find this value using the calculator, right? Now what's my only change? My only change from before here, right? Copy. Is I'm going to need the future value at n equal to 648. right? So this was 323, but no more. Now it's 648. Everything else stays the same, and I'm going to compute the future value. Okay. Let's see here. Oh, add time.
Ashley's bestsellers are in stock and
How do I close? The price of free, I guess. All right. Change my n to 648. And that's all I need to do. Isn't that crazy? Compute future value. Hey, this feels manageable, right? Now all of a sudden I only owe 1,091 and 8 or 19 pennies. You'd almost be tempted to just pay it off right then and there. But then the bank would say, what? Sure, but you got to pay us your interest that you owe us. So then here, this value is 1,091 and 19 is what's going to go. I'm going to sneak around here. 1,091 and 19. Yeah. Okay. We can do row 649. 649. Anyone? The payment amount 546.73. But be very careful with this cell here, because we're going to need to reverse engineer it. Okay. But what we're going to do is same thing that we were doing earlier, is take this principal or the previous balance times I, right, 2. Oh, I actually like it when it's smaller for my screenshots. So I have 91.19 times I have to pay $1.99 in interest. Now that's fun, right? And so I have $1.99 in interest, which means that the remainder from my payment of 546.73 is going towards the principal 544.74, which I can take away from 1091.19 minus that previous. So now what I owe is 546.45. Okay. What were the rules? The balance here has to be 0, right? How can I force that to be 0? Well, in order to force this to be 0, 546.45 has to be the principal amount, right? So here, 546.45 must be the principal amount. But I also need to find the amount of interest that I need to pay on 546.45. So then I'm going to take that previous answer times I need to pay 0.997, which is going to round to a whole dollar, right? So I need to pay $1 in interest. Okay. And so here, this value is going to equal this plus this, which is 547.45. But to have it, I'm going to say 1.00 plus 546.45. And that I'm going to screenshot and bring in. Yeah. So here, where's the work for the last two rows here? So this must be 547.45, which is going to be different. And that's always going to be the case. It'll be similar, but not exactly the same, because we have to pay off whatever's owing, right, from the second to last payment. And I need to pay interest on that payment. And so it's going to be similar, but not the same. Okay. Hey, good job. You did it. So we basically did 3 examples, right? Because they all go through the same procedure, right? The last thing we want to answer is, what are the net interest charges? Okay. So interest paid, and we've seen questions that ask this before, is going to be the total amount that you've paid minus how much you borrowed. Is the total paid minus total borrowed. Okay. Now to find the total paid, relatively simple, right? Because we have these payment amounts, remembering that, okay, it's 546.73 times 649 of those payments. And then we've got the final one that's just slightly different. So we can't really do this payment amount times 650 because it's going to be slightly off. But the total paid is 546.73 times 649 plus that last payment, which was 547.45. Oops. Minus, what was the total borrowed? 208,000. So I've got 546.73 times 649 plus 547.45 minus 208,000, which is going to be 147,375.22. Yikes. Oh, you know what? I'm going to delete that one because it's too small. It's not printing on the same page. So then this one, the previous answer, minus 208. That I'm going to screenshot. Oops. Crop. All right. Good. So this is the total paid. So total paid minus the total borrowed is the amount of interest paid, which is kind of scary, right? It costs you $147,375.22 to borrow $208,000, but that's just how banks are, right? All right, so that's it. That's the end of all the new material. No new material which means we're done Math 114. You did it. Pretty fun. Now you just have to study for the final. Well, you have an assignment on this stuff and you have a quiz on the mortgage, the amortization schedule. And like I said, I did post, so there are more in the in-class mortgage worksheet. We did the first one. Might be a good idea to just redo that one, right? Because then you can refer back to this video and maybe fill in some spots, right? If it didn't sink in the first time, then try the second one, then try the third one. And like I said, I've posted the solutions in here, right? But they're just like that, okay? So if you have any questions, let me know. Otherwise, you did so good. We'll do a final exam review next Wednesday. Crazy with the holiday. And then you'll be free. All right, so let me know if you have any questions. Otherwise, have a wonderful long weekend, and I'll see you on Wednesday again. I'll stop this recording.